Welcome to our second lab, which is going to be on programming Teensy. In this section, you will become familiar with the integrated development environment, which you will be using to program Teensy. Moreover, you will get used to handling the Teensy board by creating and running a simple Blinky program. Let us start with the IDE. The flow diagram on the right presents the code development cycle, which involves first, writing the code using some sort of a text editor. 2. Compilation. The text code is converted into binary machine code, which is also known as executable code, and that can be understood by the microcontroller. 3. Testing the code through simulation and debugging. In other words, remove defects or errors from the code until it becomes correct. Number 4. We upload the program to the hardware, test and debug it again, and finally release it. Regarding testing and debugging, notice the backstep flows on the diagram, leading to the first step, which is writing the code. On your right, you see how the Arduino IDE should look like when run on your computer. As shown in the previous slide, programming includes several steps, from coding up to building executable codes. An IDE brings together in a single framework many of the tools related to each development step. Now let us discuss the basics of Arduino's IDE. The main development window of the IDE is made up of 4 main areas. The menu bar has standard options under the File menu, such as New, Open, and Save. There are also editing options under the Edit menu, as well as other tools for compiling, like Sketch, tools for testing, and of course Help. Note that you may even find some code examples available under File. Two, the command bar. The command bar contains several tools to execute and upload the program to the microcontroller. 3. The coding area. The coding area is a simple text editor for you to code. And finally 4. The status area. The status area shows the status of the compilation, how much memory has been used, any compilation errors, and various other useful messages. By default, the coding area comes pre-populated with some code. The structure of a program has a minimum of 2 blocks, setup and loop, with each block containing a set of statements enclosed in curly braces. Setup is the preparation block, and loop is an execution block. The setup function is called when the program starts. This preparation code is used to initialize variables, pin modes, and other components of the program. While not compulsory, it is a good practice to keep initialization code away from the execution code loop. This can help to make things clearer and the program more robust. After the setup function is executed, the execution block runs next. It hosts statements like reading inputs, triggering outputs, and checking conditions. Finally, as its name suggests, the loop function executes the set of statements enclosed in curly braces repeatedly. Let us start now with the IDE. Now that you are familiar with the IDE, we will see how you can use it to load and run programs in your Teensy. To do so, we will use the Blinky program, which makes Teensy's LED to blink. Download the blinky.ino file from the unit's blackboard. You may find it in the folder of Lab 2. Then open the file in the IDE by clicking on File, Open. Look for the location when you save the file. Select the file and click Open. If you're prompted to create a folder with the same name as the file, click OK. Your IDE should look somewhat like this. Now let's look at the source code. It starts with a section in gray between a slash followed by an asterisk, and vice versa, an asterisk followed by a slash. Everything between slash asterisk and asterisk slash is a comment. In other words, a portion of the code that is ignored by the compiler. Comments are very common in programming, providing guidance on what the code does. In this case, the comment provides the program's title and explains what it does in overall. For short comments, you may use a double slash in the beginning of a line. The next line corresponds to a variable declaration. A variable is a kind of a container identified by a name, in this case lead, that can change its contents. In this case, the source code tells the compiler to reserve some memory space for a variable called lead, which can contain integer values, hence the preceding int in the variable declaration. An int type of an integer variable can hold only whole numbers between a number that is equivalent to -2 in the power of 16 and 2 in the power of 16 minus 1. This is because we are using 16 bits to represent numbers for int type variables in Teensy. Note that the line terminates with a semicolon, which tells the compiler this is the end of an instruction. The most common mistake for most beginners is to forget to add a semicolon. Next is the setup function. Functions are portions of code that can be called from different parts of your program. Instead of writing the same code multiple times, we write it only once and have the program invoking, this means calling, the function as required. Functions can also be used as a way of separating code for special or specific needs. Any parameters of a function would be listed inside the function's parentheses. Parameters are simply variables that can be passed when calling a function. Because there is nothing inside the parentheses of setup, there are no parameters passed to setup. And the function does not need any data to run. Since the function was declared as void, it will not return any data as well. When the setup function is called, what does it do? Everything included in the curly braces is part of setup. In this case, a single instruction, pin mode. This instruction is executed when the setup function is called. As it has parentheses, pin mode is a function itself, and it requires two parameters, lead and output. Pin mode is a function that tells the microcontroller what specific pin will be used and how. The first parameter in the function identifies the pin. In this case, the pin is lead, which is identified as pin 13. Regarding the second parameter, pins can be used as input. This means to read the status of the pin, in other words its voltage, or as output. This means to set or write the pin's voltage. In this case, the pin is an output pin. Outputs can be set as high, which is equivalent to logical 1, or low, which is equivalent to logical 0. The loop function is executed next. As its name implies, it runs loops continuously, as long as power is applied to Teensy. This is why the configuration should not be done here. If you put any configurations here, for example variables, they would be overridden again and again, potentially slowing down the application. In this case, the loop function has 4 lines of code and 2 functions, digital write and delay. The names of the functions are self-explanatory. Digital write has 2 arguments. The first identifies the pin, in this case the LED, and the second one the status of the pin. The status of the pin is set to high in the first instruction and low in the third instruction. The delay function tells the microcontroller to wait for a specified number of milliseconds. Digital write and delay, called in pairs in this code sample, result in blinking the LED 1 second on and then 1 second off. Let us start now with running your first program. Before running the program, check that you have selected the Teensy 3.6 board in the tools. You can also check that by looking into the name of the board that appears at the bottom of the IDE. To compile, click the Verify button. If there is a problem, the IDE will prompt a message at the bottom of the screen, indicating a line number and the cause of the problem. This is an example of a message error for a very common issue. The correct board, Arduino Mega in this example, has not been selected in the IDE. The selected one is Arduino Uno instead. To transfer the program to Teensy, click the Upload button. There is also a keyboard shortcut available, Ctrl+U. The IDE now attempts to contact the Teensy and transfer the program into the microcontroller's flash memory. A message at the bottom should soon display the text "Done uploading." Now look at the Teensy board. Click the button. The LED should be blinking, the same one used to verify that your Teensy was working in the previous section. Congratulations! You have now learned and successfully uploaded your first program. And at this stage, we have reached almost to the end of this lab session. It is time for sharing with you your second activity. The second activity expects that you experiment with the code and then write down a summary, 70 to 100 words, where you explain what happens and why. For example, you may write about how frequently the light blinks or may not blink at all and why you think this happens. One way to do so is via changing the order of digital write and/or delay. Another way is by changing the values of the parameters passed to these functions. We have now reached the end of the second lab on getting started with programming. This lab enabled you to see for the first time the Arduino integrated development environment, what a code development cycle is. We also explained what a function is, and we created and run a simple Blinky program.